Alright everybody, this is a video just to give an update 1 week after starting the Eternal Terrarium. So far it's all good. We've got moss in there, evergreens, and one conifer clipping. Look, you can even see on this leaf right there, the water has gathered, so the water cycle in there is very strong. And no signs of any bug life yet, but you never know what might come up from underneath of that moss that we transplanted. And then we'll go and we'll take a look at the other Eternal Terrarium. And, oh, what do we have here? Something about to happen. Alright, let's take a look at this Eternal Terrarium. So far, so good. It's pretty wet in there. Remember, the plant provides its own moisture. So we open it up. Oh, yep. Plant's still going good. No problems there. So far the Eternal Terrarium is a real thing that you can definitely do yourself. Nothing hardly to it. Easy to do with kids. Alright. Hey there, Nana. Today's experiment is going to be, we're going to do a few things. We're going to do some dry ice. That's what's in this cooler. And guys, this is $2 a pound at the Airgas. And one guy told me, if you tell him it's for education, he might even give it to you for free. And then over here we have some Pyrex glass, some just regular water, and a little jar there that might be sacrificed. We'll see how high these temperatures get. Theoretically, if it does turn to plasma, it might get pretty high. I'll move off the plant off the terrarium here. Alright, so first let's talk about dry ice. Why do they call it dry ice, Orion? Look what 3 pounds will get you. That's huge. Listen to this sound. Why is that happening? See how cold that is. Instantly cold, right? Alright, so what's the difference between dry ice and wet ice? What's the difference? Right, but dry ice is not water. It's carbon dioxide that's been frozen, and now it's undergoing what's called sublimation. And that's where you can see the ice down there at the bottom. It's instantly going from solid to gas. Even if I left one out here on the counter, it would do the same thing. So I'll take a piece here, I'll take a small one, and let's put it down here. And you'll see it's producing a little bit of, quote, fog. But dry ice fog is actually carbon dioxide. So can we breathe this in? No, you can't breathe that pure in. And look how it falls. Why does it fall? Because the carbon dioxide is denser than the air around it. Even though the air around it has carbon dioxide in it as a mixture, it is less dense than the carbon dioxide, which is pure. Now as it goes down there, it gets mixed and starts to blend. It'll rise again and swirl and becomes invisible. And right now, as it comes out, you can see it. So it's quote boiling, but it's not really truly boiling. I mean, it's sublimating, so it's going from a solid straight to a gas without being a liquid in between. That sound you were hearing is the reverse of what we saw with the bismuth melting and exploding the ceramic. The same thing, thermal shock. So when I push this in there, the metal instantly cools and starts to flex as it contracts the metal, and it makes that crinky sound. Now check this out. If I take this, oh, it even made a whistly noise. And watch this. I put it on glass. Listen. Oh. Let's see. Now sometimes it does it and sometimes it doesn't, but it'll make a vibrating noise. There it goes. Right, while the temperature is oscillating, it's trying to reach equilibrium, so it vibrates. So no different than when I put that pot onto the stove and it was vibrating back and forth. Okay. And see, this will continue to boil for a long time until all of the carbon dioxide is actually sublimated out. Right? You can touch this. You can even touch the water. It's not frozen. Go ahead.
It's cold.
Yeah, it's cold. It's cool. Now there were some people that were doing something that isn't too bright. They were putting dry ice and liquid nitrogen into
really
drinks to drink, and someone got actually hurt by this. So we never drink what's in here because that dry ice is still more than -200 degrees Fahrenheit.
Is it really hot?
It's not hot. It's just not ice cold like you would think. Now, would I plunge my hand deep into this? Into here? No, no. Now, I could touch it, but that's just briefly. It will stick to you. But if you were to plunge your hand deep in there, it would be very, very cold. It would be very, very bad. So that's why we call it being safe. But look at this. I mean, it's it's just sitting there. Now, we would never put this kind of ice in our mouth and chew it. Right? That'd be a very big mistake. You understand that, Nina? This ice can't be chewed. Everybody got that? Okay. So in part 2, what we're going to try and do, now that we've established what dry ice is, we're going to try and induce a plasma interaction in this microwave. We're going to also microwave the dry ice by itself and see what happens. And we'll see if we can get the plasma to come out. This light might be a problem. There might be plasma going on and the light might overshadow it. So we're going to see what we can do. This is a brand new microwave. Well, brand new for us, right? We don't traditionally own a microwave here at the house. It came from the clinic. But after we're done using this microwave for a few experiments, we're actually going to take this microwave apart and use it for its electrical powers that it can provide. It's got transformers inside, and it can direct radiation to do useful things. So there'll be more videos of that sort. If you have any questions, put them below, and like, subscribe, and share to your other parent friends.